This video, I'd like to use HTML and JavaScript, and I'm going to create an SVG drawing a design known as the quatrefoil. So here's the Wikipedia page on the quatrefoil. And basically, you start with a sort of a cross shape, and then at the ends of the cross, you draw circles and then find out where those circles intersect. So you can have, they call it here, the more overlap and the less overlap. So you can have, you're drawing a circle and you can have a large part of the circle, the majority of the circle, or sort of less of the circle. That will um, come up in the math that we use to figure out the points of these intersections, but also in the code. When you draw an arc, you specify uh, the 2 points of intersection, but also do you want to draw a lot of the circle or a little bit of the circle? So we will see that coming up. Um, but let's start with the calculation. So I needed these intersection points here. So I'm using this figure. Uh, I have the red part here is sort of 2 parts of my cross. And I said that from the center of my cross, which is also the center of my quatrefoil, I'm going to go a distance z up, uh, and the center of the circle is going to be z from the center of the cross or the center of the quatrefoil. And then I assumed that the radius was 1, just to make the math a little bit easier. And then I wanted to find the distance from the center of the design, the center of the cross, the center of the quatrefoil, to the point where the circles intersect. And we see that there are actually 2 points. We're going to be interested in the outer one. And given that this happens on this cross shape, we can sort of easily convince ourselves that that intersection point lies on like a 45-degree angle. Okay, so we set up just a basic, I don't know, I'll say vector, um, that in this coordinate system here, where this center of the cross or the center of the quatrefoil is the origin, then uh, this point uh, is if theta is an angle in this upper circle, then the horizontal is cosine of theta. So say if theta is from the horizontal down to this radius, then the horizontal is cosine of theta. But the vertical in this coordinate system is going to be z plus sine of theta. Okay. In this coordinate system, drawing that theta may be a negative theta, maybe, but okay, there we go. And then we know that that lies upon this 45-degree angle, and the cosine and sine are both 1 on the square root of 2, or 0.707. So this point is 0.707 r for both of these. Okay. So this gives me sort of 2 equations, the x component equation, the y component equation. And then I can use also the trig identity of cosine squared plus sine squared is equal to 1 and solve this for cosine, which it already is, and solve this one for sine, and then substitute in, and that gives me an equation for r in terms of this z. Okay, and then we can use the standard quadratic formula to find r for z. And we will see that over in the JavaScript. Okay, so that is the geometry. And now let's go over to using that geometry to actually make the design. Okay, so I define some style It's basically just black and white, so there's not much style, but I'm defining a parameter in my style, which is 300 pixels, but this allows me to, I can just change this and change a lot. And then I'm making, and I call that half size, and then I make an SVG, which is 600 by 600. Okay. I make a space in my HTML for, I'm going to draw 4 pictures. I call them quatrefoils. Only the first 2 will be quatrefoils, and the other 2 will be similar, but not quite the same. But you'll see when the time comes. So now I'm starting my script. So we see that those are all empty SVGs, and then they're going to be populated. The design is going to be populated by JavaScript. Okay. I'm expanding my namespace. I'm getting that parameter, which was a style parameter, now down into it, get a JavaScript version of that. And I'm defining my the radius of my circles, and I want to draw as some fraction of m. So m is sort of half the size of sort of like half width or half height, and then some fraction of that is the radius of my circle. And then I'm getting this. For some reason switched from Z in here to F. Okay, but so F is this uh, parameter that tells me like the length of the cross to the centers of the circles. Okay. Um, and then I can find the radius of those intersection points, that sort of capital R. Okay, and so we can see here this quadratic formula, and then my quadratic formula is some number, and then I scale that by this radius. So in my image here, my radius is 1, but then everything must be scaled by R. Okay, so my formula was f on the square root of 2 plus the square root of 1 minus f squared on 2. And that gives you that discriminant here, this square root here will put some limits on what f can be. All right. Um, and everything, square root of 2 is all over the place. Because of the 45 degrees. And I decided here to call it cosine of 45. But cosine of 45 and sine of 45 are the same, but I didn't want to have 2. Okay. So here's me drawing my basic quatrefoil. So I have a thing that SVG calls D, which is a property of a path. And I start off with a point, and MM are the coordinates or sort of the center of my image. So I don't have a 0, 0 as my origin, but I have an MM. So everything's got to be, M's got to be added to everything. And then here is my R cosine theta and R sine theta, but sine theta and cosine theta are the same if it's 45. So that is one of my points in my sort of cross. Where am I at? So the horizontal is positive and vertical going down is positive when I'm drawing things in code. So I think I'm starting here. And then I am subtracting. So I'm going sort of up in vertically. So I think I'm starting down here and going here. So I think I'm going around this sort of loop counterclockwise. So those are my points. Plus, 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 minus, 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 plus, and back to plus, plus. Okay. So M is the original point where I'm starting. A means I'm drawing arcs from one point to the other. An arc has, in SVG and JavaScript and such, has two radii because it's strictly speaking an ellipse, but we're drawing circular arcs, so our two radii are the same. And so we have our starting point and our ending point of our first arc, and our radius of our arc, and then we have these three parameters in here. The first parameter is sort of an angle of rotation of the arc. So again, the arc is typically or generally a ellipse, and we're drawing circles. So then that angle of rotation will be meaningless for us. So I just made them all zero. So 0, 0, 0, 0. Okay. Then the other two parameters, we basically have we're thinking of, we have a beginning point and an end point. So think of drawing a chord between a chord between those 2 points. And then we have, do we want to draw a big part of the arc or a little part of the arc between those two intersecting points? That's one of the parameters. And then sort of where's the center? Which side of that chord is the center on? So that's what these sort of numbers sort of are related to. And so when I originally drew it, I drew it with 1, 0, 1, 0, 1, 0, 1, 0, and made my path, and then added my path to my design, and set all various parameters, the fill, the stroke, what have you. And uh, there is that quatrefoil that I just made for an F, or what I was calling over here Z, of 0.5. Now, if I make this F or Z quite small, then I should be heading toward these sort of uh, almost concentric circles. I mean, as Z becomes as small, it's almost concentric circles. But we're going to see that that doesn't quite happen, and then we'll explain why. So I made it a Z of 0.1, pretty small. Then I better change it back. Um, and so, according to my calculations here, we think we're going to have some very sort of like almost concentric circles overlapping thing. And that's not what happened. Okay. So let me take it back to zero point 0.5 before I forget. But we know why that is. That's because of the way arcs are drawn. So we made a choice of F that we thought was leading us to this, more of this design, but we kept this design because we, in our parameters on our zeros and ones that we were showing, we were saying draw a lot of the circle. And so when we started drawing less of the circle, in as Z became small and we're expecting it to be more like this, that those parameters of drawing arcs and pushed us back in the other direction. Okay. So then uh, that made me skip over this commented out section, come back. This made me ask, let's draw all the other combinations. Again, the first parameter is about a rotation. We have circles, so the rotation is meaningless. But I drew it with parameters of 1, 0. And so I'm drawing the other combinations, 0, 0, 1, 1, and 0, 1. So those are my other designs on the page. So there's the one quatrefoil. Here is the quatrefoil. You can barely see that it's quatrefoil because they're so close. There, let me refresh it. I had changed it to 0.1. Now let me change it, refresh the parameter. So now we see this sort of strongly overlapping one. Again, I'm just using the notation of overlap and less overlap. So I'm using that terminology, if you will, from Wikipedia. So this is not overlapping much, and this is overlapping much. And it's the same intersection points, but I'm just using different parameters here in my. So I went from 0, 1, 0 to 0, 0, 0, and then 0, 1, 1, and 0, 0, 0, 1 were not quatrefoils, but things related to quatrefoils. I'll call this some kind of petals and flowers, sort of an interesting design, some cousin to the quatrefoil, but not a quadrifoil. And I'll call this one, I don't know, maybe an asteroid. So we can see here these circles, but they have intersections, addition, not just one point of meeting, but multiple points of meeting. So they're not the same as the first and second, which are really genuine quadrifoils. Okay, so that's the difference between these arc things. Okay. And then one last thing I wanted to show was here on the Wikipedia page, they've got sort of a second quadrifoil, um, which has, if I'm thinking of the centers of the circles, then it's a concentric circle. So like so I have four circles making up the quadrifoil, and then if each circle had a concentric circle to it with and okay. So now that is so I'm going back to my calculation. I want something that's a little bit more than one in this calculation to have a bigger radius. I want the z to stay the same to make the circles sort of stay the same. So I'm going to expand uh, this radius by a factor I'm going to call w. So I'm going to multiply it by w. And then I want this to stay the same. So I'm going to sort of divide the z or f by the factor w so that w times r stays fixed. And so these will have the same center. And then I'm going to redo my quadratic formula here to find the intersection point. Okay. And what we're going to, so here was the original quadratic formula. That the radius where the points meet was related to this f, and then everything got multiplied by r. Now I'm going to bring this new part out, and I am multiplying r by w. I've just produced 1.1 just arbitrarily, and I took R2 and multiplied it by the W. I took F2 and divided it by the W. So that way, when I did R2 times F2 for where is the center of the circles, which is not part of my path, but it's important in figuring out where my paths meet. And I want that to stay fixed. And then here is the new quadratic formula, F2 being replaced, F being replaced by F2. I multiply it all by R2. That all makes sense. And then here, what was above 1 now becomes W squared. Okay. So that's the new quadratic formula. And let me draw it. And I want, it's this one that I did that extra bit too. Now, remember, we had the whole thing of what part of the arc am I drawing? And so I can, uh, my calculation is the change in my calculation is based on sort of a reasonable size z. Um, and if I did made too much, if my z or my f say was too small, or I changed it too much, then I may end up changing the amount of the circle I want to draw, or somehow messing up my calculation. So uh, for the for this f of 0.5, this adjustment works, but it won't necessarily always work because of the calculation is sort of based on what part of the circle I'm drawing, and if that gets changed, then all bets are off. All right, that's what I wanted to show. Drawing a quadrifoil, uh, the two versions of the quadrifoil and their sort of cousins, and this sort of concentric version. All right. Thanks very much for your attention.